Imagine a robot who could navigate through a building and find humans who may be in trouble. Elizabeth Cocolet joins us now in the studio to tell us about her robot who does just that. Welcome. So tell us about the robot, just generally. What does it do, and what are some of the features that you've designed here?
So what it does is it can navigate autonomously through a hallway blueprint. So I just let it go and it navigates all by itself through hallways. And while it's doing that, it searches for people using an infrared camera, which finds them based on heat. So if there was hazardous waste or toxins or a bomb or risk of the building falling down and a human searcher couldn't go in, the robot can go in and look for people who might need to be rescued.
And this seems like an amazing project, and you're 18 years old, you're from Cleveland. Just a little background on you. How did you come up with this idea?
Well, actually, in middle school, my school has us all do science fair projects, and I did a robotics project. It was a warehouse delivery team, so they sorted and delivered warehouse orders to people, and I really liked that. So then when I went into high school, there's a program at my school that pairs students with professionals or researchers, professors, doctors, people like that. So I asked to be paired with a robotics professor, and so I've been working with him. His name is Wyatt Newman, for the last 3 years at Case Western Reserve University.
Wow. So this is a 3-year ongoing project. You build on it from then. You're in Washington for this big competition. Tell us a little bit about that.
So it's called the Intel Science Talent Search. And basically you submit a big paper, a 20-page paper about your work. And there's a pool of about 1,600 applicants, and they pick 300 semifinalists and 40 finalists. And if you're a finalist, you get to come to Washington, D.C., and they have various festivities, dinners, you meet important people, and then you are judged for different scholarships.
That's great. That'll be exciting. And the judging is today?
Yes, today and tomorrow and Sunday.
Wow. Are you nervous? Are you excited?
A little bit, yeah. It's kind of a unique judging process, so I don't really know what to expect, but I think it'll be exciting.
And you've done these big competitions before. You were telling me you worked on a project with a car?
Yeah, I worked on a big project for a competition called the DARPA Urban Challenge, which is run by the Department of Defense, and basically big teams from universities and actual professional companies to create full-size robot vehicles. So it's like an actual car that can navigate all by itself through live traffic. And we all went out to California. The people who were picked as semifinalists for that went out to California, and we tested our robots on big courses with stunt cars and all this cool stuff. And then there was also prize money and things for that. So that was really interesting.
And that let you build on what you just designed
Exactly,
here.
Yeah. From there I got a lot of resources. I got to know a lot of people who could help me out. I got a lot of skills that I needed to do this project.
Okay. And we're going to take a look at some of the pictures of your robot and have you explain exactly how this functions, how it works. Like we see here, can you just kind of explain what this device is, where everything is on here?
So this is the robot. His name is Leo. So he has two main sensors. The two on the front, the tan sensor that says SICK on the front is a LiDAR laser range sensor. So what that does is it sends out laser pulses to see obstacles and walls in the environment around the robot. So it uses that to navigate. And then the black sensor in the clear box is an infrared camera, which senses heat. So it can sense the heat of people. And then also there's a lot of electronic equipment on there. There's computers, there's a big screen that displays sensor values and can also display the coordinates of where the people are. So yeah, that's...
Okay. And how does Leo get around? Does he have wheels? Like, how does he go into buildings?
Yes, he has wheels, and he's given a blueprint beforehand. So he has a plan that he's supposed to traverse, and then you just let him go, and he wheels around the building, and then is programmed to come back to you to report coordinates.
Wow. And is there some situation that gave you this idea? Did you see something where this was needed, or how did you come up with this idea in particular?
Actually, there's a huge need right now for autonomous search and rescue robots, because having a robot be autonomous is really difficult because situations can be really complicated and chaotic, and the robot needs to be able to react to different situations. So right now, a lot of robots are either remote controlled or only have some autonomous properties when they are actually used right now for search and rescue situations. So building an autonomous robot is really helpful, because then if there's some reason why you can't communicate with the robot, or some reason why the situation is too chaotic for humans to really have a good grasp on the situation, having an autonomous robot can be a huge advantage to finding people efficiently.
Okay. And let's talk a little more about Leo. I'm making him very personal here, because he's very much like a human.
Yeah, exactly.
And when he goes in, there's these sensors, of course, but also he can print out the images of what he sees in there. Is that one of the features?
Yeah, well, he actually displays them on that big black screen. So he displays coordinates that he's found of the people, but also as he's going around, he's keeping track of everything that happens. So when he comes back, you can actually watch a live video feed of everything he's seen, and you can watch a live infrared video feed, which shows all of the heat of what he's been seeing. So there's it's a grayscale image with warmer things are shown white and darker things are shown black. And you can also see everything, all the decisions he's made, where he's steered. You can see graphs of where he's gone through the hallway blueprint.
Wow.
So, yeah.
That is amazing. Well, we wish you all the best and good luck in this competition and your judging today. I'm sure you'll do great.